Hey, if you just finished watching the last video, we talked about how, in theory, we should get the number 2 1 and 6 times. And with the experiment we did, we actually got the number 2 3 in 15 times, which we can simplify to 1 and 5. Those are pretty close, but they're not the exact same thing. Now let's talk about how to make a prediction. Let's say we want to know, in theory, we'll call this T for theory, for our theoretical probability. In theory, I'm going to roll this dice 100 times, and I want to know how many times do I expect, in theory, to get the number 2. I'm going to set up a proportion. This is stuff that we've done a few chapters ago, where my proportion is this theoretical probability, right, that we already came up with, 1 over 6. And I want to know, hey, in theory, how many times should I get the number 2? Then we can just use our fish method to solve. 1 times 100, 100 times 1, same thing, divided by 6. You can use any calculator. I have the calculator on my phone. I'm just going to do 100 times 1, 100 times 1, and that equals 100, and then divided by 6. So in theory, I expect to get the number 2 16.6 repeating times. Make sure you read the directions. Sometimes they're going to ask you to round. So I'm going to actually round that to 17 times. Please read the directions, though, to know how much they want you to round. So rounding to 17 would be rounding to the nearest whole number. So that's in theory. We expect it 17 times. If I was to roll the dice 100 times. Now let's look at experimental probability. Based on our experiment, let's find out how many times do we expect to get the number 2. Again, if I roll it 100 times, how often do I expect? Now, I could use 1 and 5. I could use 3 and 15. Because they're actually the same fraction, just one is simplified, you'll still end up with the same number. And I want to know, hey, based on my experiment, how many times will I get it? So I'm going to do 100 times 1, 100 times 1, divided by 5, equals 20. Based on my experiment, I expect to get the number 2 20 times. And now this was based on 100 rolls. I could do based on 250 rolls. I could find the theoretical and experimental probability, right? Whatever number of rolls or flips, if you're flipping a coin, or random draws, if you're drawing out of a hat, it doesn't matter. You can put that number in the bottom and use your fish method. So it goes like this. Use your fish method to solve.